So here's some other new features in this release of RSpec. I'm going to click here on Appearance and then show you here under Labels. We now have an additional 24 labels going up to 48. And that's for guys who are doing spectroscopy of the sun, who sometimes have a large number of lines. Now this is another nice new feature. You know, getting the right exposure levels for the best signal to noise ratio is important, and we have this new pixel map button here. Each cell represents one pixel between our orange lines here. So these are the row numbers here and the column numbers that we're looking at, and we can scroll around horizontally, as you can see. So these cells contain the signal level, the ADU signal level that came from each cell, and as we scroll around we can see what those levels are. Now let's come over here, and with the left control key I can bracket in an area. Now it will be just between the orange lines and inside of that red box. So it uses the left and right sides of that box. And now we can see that area there corresponds to our star, and you can see that we're at 255 units, so we've basically saturated those cells. This is a video camera. So you can see at the bottom here it says it's an 8-bit image, so the maximum pixel value is 255. Let's look over here, because it doesn't matter the saturation of the star, we really want our spectrum to be exposed well. And that means not hitting 255, but not being all that much less than it either. As we scroll over to the right, we can see, for example, now that we're in the spectrum, some of the pixels we've definitely saturated to 255, but there's quite a few others that aren't that high. So what we want to do with most cameras is get up close, but not all the way up to the saturated level, in this case with a video camera, 255. Most modern cameras are good to 70, 80, 90% of their saturated value before they become nonlinear. Let's look at this FITS image here. I'll bracket it in. Now this image too, if we come up here to options, you'll see I'm going to leave 32-bit processing off first. Let's look at the pixel map here after we've bracketed in an area by holding our left control key down and the mouse button. Now these values are also in the range of 0 to 255, and it says down here this image is being displayed in 8-bit mode. So even though it's a 32-bit FITS image, it's being displayed in the range of 0 to 255, which is fine for most of the work that we do. If we want the full precision, we come here and put a check mark. Now that's going to slow the software down, and generally we don't need that kind of precision for a lot of the work we do. But now we can see values that are much more reasonable and reflect the data that came from the camera for each pixel. Now again, typically with a camera we can go up to 40, 50,000 ADU on a more modern camera and still have linear data. So this is a good way to examine your spectra. It's similar to a histogram function, but it lets you see a little bit more of the detail. Now let's take a look at another feature here. I'm going to turn that off, and I'm going to come back to this Vega spectrum. There we go. Now we're currently in angstroms. In fact, I'm going to turn that off for a second. Let's click on Calibrate, and I'll come down here and click on Reset, and then close it. So now we're in pixels. This is a neat little shortcut for you, and that is, if we've been on the Calibrate screen before and we've done a save, then now we can just hold the Control and Shift key downs and hit Calibrate, and it reloads that file. That's a convenient feature, especially if you're a programmer and you might be doing this dozens or hundreds and hundreds of times a day. So now we're calibrated in angstroms. Watch this. When I click to fill in this box, we now have synthesized the spectrum under the curve. Again, scientifically it doesn't provide a lot of new data, but it's great for outreach. It's great for an intuitive understanding of what's going on, so we can see exactly where the light and the spectrum is falling. Now here under Appearance, one thing I did, and I shot myself in the foot on this on occasion, I turned the line color to black like the background. That makes the display even neater. Now you don't see that red line in the background. So this is a great display. Very intuitive, very exciting. Of course you can print this out and copy and paste it and so forth. Now here we've got some noise, which is interesting to look at in itself. So you can see there's lots that we can do with this feature, but as I said, the neatest thing about it is how intuitive it is. But be careful if you turn that line color to black, because you can confuse yourself, because once it's the same as the background color, you may have trouble finding the line because it won't even be visible when you actually have data. So here on the zoom window we've added this vertical overlay line just to help with alignment when we're rotating. Let's bracket in here so we've actually got data. Now typically we're not going to want to rotate on scientific data because sometimes it can introduce artifacts. Now let's zoom in a little bit, and you can see with that overlay it can make it a little easier for you to spot when your spectrum is vertical. If we were using the rotate command, that would be a little bit more clear. Now let's go up here to the options screen and go to the advanced tab. I'll show you a new option there also. Down here we can now display in nanometers rather than angstroms. The data files are still in angstroms, but that can be helpful when you're presenting to audiences or you're working with data that's more appropriate in the nanometer range.